6,000 years ago, for the first human civilizations in Mesopotamia, the night sky was not empty but crowded with gods and their endless dramas. And on the plains of Mesopotamia, the priests of Babylon climbed their ziggurats night after night to watch, because the gods were speaking and their language was light. In the beginning, they said, there was only water, the fresh water of Apsu and the salt water of Tiamat, and their mingling gave birth to the first gods. But the young gods made so much noise that they disturbed the peace of their ancient parents, and from that disturbance came war. Marduk, the great god of Babylon, eventually slew Tiamat and carved the universe from her body, splitting her like a shellfish so that her ribs became the vault of heaven, while her weeping eyes became the Tigris and Euphrates rivers. The Greeks told a different story, though the pattern remained the same. For in the beginning was chaos, not as confusion but as a yawning emptiness. And then came Gaia, the broad-breasted earth, and then came Uranus, the starry sky, who covered her completely and hated the children she bore him. When the sun rose each morning, it was not yet understood as fusion, but was instead Helios driving his golden chariot through the gates of dawn. And when thunder crashed, it was not atmospheric discharge, but Zeus hurling his anger from the heights of Olympus. Every phenomenon had a face, and every event had a motive behind it. In this world, the Big Bang Theory would have been not just wrong but genuinely incomprehensible, for an impersonal explosion without intention or made no sense in a cosmos where nothing happened without someone willing it to happen. The universe was eternal because the gods were eternal, and there was no before because there was only the story. Then came the philosophers, and with them a great leap forward, for the Greeks discovered that the world might be understood through reason alone, and that beneath the chaos of appearances there might lie a logical order accessible to the human mind. They looked at the sky and no longer saw gods fighting, but instead saw patterns and principles and mathematics, and this was liberation from the old stories, because it meant that anyone with enough thought could understand the universe. But this leap forward came with chains attached, for the philosophers became so enchanted with logic that they began to believe the universe must conform to reason rather than reason conforming to the universe. In geometry, a circle cannot be a triangle, and everything follows necessarily from first principles. So the philosophers asked whether the universe could be any different than it actually is, and they answered with a firm no, because it must be eternal and unchanging in its deepest nature. They did not bother to look at the world to check their assumptions, because why would they need to, when reason alone could unlock every mystery? And this is why Aristotle, who came closer to empirical investigation than any philosopher before him, could still declare that women had fewer teeth than men without ever thinking to count. For the philosophers, the universe was a logical necessity, like a mathematical proof, and it could not have had a beginning because a beginning would violate the very structure of rational thought. Nothing comes from nothing, they said, and time cannot begin because before time there is no before. So the cosmos must have always existed, and this was not a conclusion based on evidence but on pure deduction from first principles. Christianity shattered the philosophical consensus without meaning to, for the Hebrew scriptures declared that God created the world freely and not because he had to, and this meant the universe was not a logical necessity but was instead contingent on God's free choice. The Creator could have made the universe any way he pleased, and he could have chosen not to make it at all. And this single idea cracked open the Greek assumption of an eternal cosmos. Because if God decided to create, then there was a moment when creation began. The universe had a birthday and it could have been otherwise. And this meant you could not sit in your study and deduce the properties of the cosmos through pure logic, but instead you had to go and look at what God actually chose to do. This idea laid the groundwork for empirical science without intending to, for if the universe is contingent, then observation becomes essential. But the church immediately locked the door it had opened, for while it insisted the universe had a beginning, it also insisted that the beginning was exactly as described in Genesis, and no other explanation would be tolerated. The universe could not be too old, and it could not follow any mechanism that contradicted Scripture. So the beginning was real, but it was also settled, and no further investigation was permitted beyond what the Church already declared. When Galileo turned his telescope toward the heavens, he saw things that challenged the biblical picture, moons orbiting Jupiter and mountains on the moon, and the Church silenced him because his observations threatened their authority over the beginning. Yet the seed had been planted that the universe might have a genuine beginning, and that we might learn about it through observation. The scientific revolution began with deeply religious men who carried that Christian seed within them. For Newton believed he was thinking God's thoughts after him, and Kepler saw his astronomy as discovering the harmonies of the Creator. Because God could have made the universe any way he chose, they had to observe to discover which way he actually chose. And this approach yielded spectacular results that transformed human understanding of the cosmos. But as science advanced, it slowly forgot its theological roots, and the community gradually adopted methodological naturalism, which meant explaining nature using only natural causes without reference to divine intervention. With this shift, an old friend returned from the ancient world, the idea of the eternal universe that the Greeks had declared by logic, and that now seemed obvious to scientists who thought they had outgrown such assumptions. Things change, they said, but the whole cannot change, and matter cannot be created or destroyed, and the universe must always have been here. And this was not presented as a theory to be tested, but as a background assumption that needed no defense. The eternal universe became the water in which the fish swam, so deeply embedded that no one thought to question it, and any suggestion of a beginning was met not with argument but with dismissal, because everyone knew the universe was eternal. The Greeks had declared the universe eternal by logic, and now modern scientists declared it eternal by instinct. And the refusal of the beginning took on a new form dressed in laboratory coats and mathematical equations. When Albert Einstein completed his general theory of relativity, he had equations of breathtaking beauty and power, and those equations contained a disturbing implication that Einstein himself could not accept. The mathematics suggested that the universe could not be static, but must either expand or contract, and if it expanded, then working backward in time, it must have had a beginning when everything was compressed into an infinitely dense point. Einstein found this implication so offensive to his scientific intuition that he added a term to his equations called the cosmological constant, specifically designed to cancel out the expansion and force the universe into a static eternal state. He made the equations say what he already believed rather than following where they led, and this was not a mathematical error but a philosophical one, because he trusted his assumption of eternity more than his own mathematics. When Edwin Hubble later discovered through his telescope that galaxies are actually moving apart, proving that the universe is expanding exactly as the original equations predicted, Einstein called the cosmological constant his greatest blunder and removed it from his equations. But the lesson was clear. Even the greatest mind in physics could not escape the gravitational pull of what everyone knows and what has always been assumed. Einstein's blunder stands as a monument to human resistance, a reminder that evidence alone is never enough when it contradicts assumptions we have held for 2,000 years. When Georges Lemaitre, a Belgian priest and physicist, first proposed what would become known as the Big Bang theory, the scientific community responded with hostility and pointed to his priesthood as proof that his ideas were religious rather than scientific. Fred Hoyle coined the term Big Bang mockingly during a BBC radio broadcast, intending it as ridicule, a dismissive label for an idea he found absurd, and he championed an alternative called the steady-state model, which held that the universe was eternal and continuously created new matter as it expanded. For decades, these two views competed, the Big Bang with its uncomfortable beginning and the steady state with its comfortable eternity, and many scientists preferred the steady state precisely because it avoided the theological implications of a creation event. In 1965, two engineers named Penzias and Wilson were working with a large radio antenna and kept detecting a faint hiss of radiation coming from everywhere in the sky, a hiss they could not eliminate no matter how much they cleaned the equipment. They eventually realized they had discovered the cosmic microwave background radiation, the afterglow of the Big Bang itself, the smoking gun that the theory had predicted and that the steady-state model could not explain. But even then the resistance continued, and Hoyle and others tried desperately to explain the radiation within the steady-state framework rather than surrender the eternal universe they loved. One piece of evidence was not enough to kill a 2,000-year-old assumption, and the debate dragged on for decades. In 1992, NASA's COBE satellite released its first images of the cosmic microwave background, and the world of physics changed forever, for the radiation contained tiny variations, fluctuations in temperature that matched exactly what the Big Bang predicted would be the seeds from which galaxies would eventually grow. The images confirmed the theory with a precision that left no room for reasonable doubt, and Stephen Hawking called it the discovery of the century, if not of all time, his announcement carrying the weight of official surrender from the old guard. In 2006, Mather and Smoot received the Nobel Prize for their work on COBE, and the Big Bang was no longer a theory but established fact, taught in textbooks, and accepted by every serious scientist.